We will solve our first example. In this example, we have two DC source, minus 2 volts and 3 volts. We can add many other DC sources along with it. For this example, we have two. We will try to find the output voltage. We don't have to memorize the output equation. We can use the inverting amplifier equation for this case. The inverting amplifier equation is minus RF by R multiplied with V. Our feedback resistor is 10 kilo ohm. Our input resistance is 5 kilo ohm. We are going for each channel, individual channel. We will finish through this channel, then we will go through this channel, then we'll add them together. Divide by 5 kilo ohm multiplied by 3 minus 6. For this channel, for the first channel, we get minus 6 volts. Remember, we said we don't add the input voltage directly. Instead, we take the input voltage, we multiply it by the gain, then we add them. This is the multiplication gain. Input voltage multiplied by the gain value. Then we go for this channel. Minus 10 divided by 10 into minus 2. So the total output voltage is minus 6 plus 2, which is minus 4 volts. If we simulate this on a simulation software, we will get the exact same results. So I have drawn the circuit diagram on a simulation software and provided the values based on the example. Let's look at the output voltage. When we calculate the output voltage, we got minus 4 volts. In our simulation software, we got the output voltage as minus 3.99, which is minus 4 volt. Example number 2. In the previous example, we had DC voltage source as the input. In this example, we have DC voltage source as well as an AC source. So to solve this circuit, initially we will deal through the AC sources first. So the equation is minus RF by R into voltage. RF is 10K. RF is the feedback resistor, divided by 10K multiplied by minus 3. Plus 3 for the first channel. For the second channel, we get minus 4. Then we calculate the total for the DC. We get minus 1. This minus 1 will act as an offset value. This minus 1 will act as an offset value. Now let's look at the AC waveform. Now let's look at the AC waveform. The AC waveform has an amplitude of 1 volt. We consider this amplitude as V in. That means input voltage. So we use the same equation. RF is 10K. R is 5K multiplied by 1. So we get minus 2. So we found the DC voltage. We also went through our AC waveform. The new output voltage will have a different waveform compared to the input waveform. So our previous waveform started from 0 and the amplitude magnitude was 1. Our new waveform will start from minus 1 because this is the offset voltage, and our new waveform will have an amplitude of 2, magnitude 2. So to calculate this value, you take the offset voltage minus 2 because we are in the negative side, and to calculate this voltage you go through minus 1 plus 2. You get 1, and on this side you get minus 3. If we run this circuit in our simulation software, we will get this exact same results, and we will verify it. For our second example, we have our waveform, a sine waveform with an amplitude of 1 and a frequency of 1 kilohertz. The DC sources are the same, 2 volts and minus 3. The resistors are 5k, 5k and 10k according to the theoretical calculation. So let's see at the output. This is the waveform we were provided. In this waveform, VF1 is the output and VG1 is the input. VF1 is the red waveform. The offset is -1. That means the waveform starts from -1. The amplitude is 2. That means 1, 1. That means 2. -3, the maximum values, the maximum peak values, which we were expecting according to the calculated value. This will be our third example. In our first example, we saw DC source and a DC source. In our second example, we saw an AC source and a DC source. In our third example, we will have an AC source and an AC source. That means two different waveform will be combined together. For our first channel, we have a waveform of amplitude 1 volt and a frequency of 10 kilohertz. For our second waveform, we have 100 millivolts as the amplitude and 1 kilohertz as the frequency. We'll combine this together. Before that, we have to find out their gain using the inverting amplifier equation. Inverting amplifier equation, minus RF by R into the input voltage. RF is 10 divided by 10, which is 1, multiplied by 1, which will give us minus 1 volt amplitude for the first channel. For the second channel, 10 minus 10 divided by 1, minus 10 divided by 1 multiplied by 100 millivolts, which will give us 1000 millivolt, which is equivalent to 1 volt. So minus 1 volt. Minus 1 is minus 2. Our new waveform will have an amplitude of 2 volts. Now if you simulate this, the yellow graph is the first channel, the green graph is the second channel. The green graph has an amplitude of 100 millivolts, that's why it is a bit below. The red graph is the output. The red graph has an amplitude of 2 volts, so it starts from 0 and reaches up to 2. This red graph is a combination of the two input graphs. I hope I covered all the topics. That's it for today's video. Thank you for watching.